Yes, good afternoon, guys, to all of you. I welcome you all on this wonderful platform that is BYJU'S exam prep. So please tell me, am I properly audible and visible to all of you or not? So guys, finally, this is the session related to engineering mathematics. And today we are going to discuss about the problems of system of linear equation. And not only problem, I will also tell you the concept about that. And guys, this session is very useful for ISRO, because if you will see the previous year's papers of ISRO, every year one question from mathematics is coming, and from matrices a large number of questions have been seen. And also obviously majorly it is for GATE and ESE also, because in ESE paper one also mathematics is there. So this session is equally important for you can say GATE, ESE, ISRO, and it is for all the branch. Okay, so we are starting the session, guys, and this is some detail about me. And this subject going on is engineering mathematics, and my telegram channel is mechanical by Dheeraj Sardana. So do join that telegram channel to get all the important updates and PDF of the session. So guys, now we are starting the session. I hope I am properly audible to all of you. And guys, this is something about the scholarship test. So you can appear in the scholarship test on 26 November, that is today, anytime between 9 a.m. to 9 p.m. and you can get up to 90% of the scholarship on GATE preparation program for GATE 25 and all. And guys, also on 29th I will be taking a workshop for strategy to secure AIR under 100 in GATE 25, and that will be at 7:30 p.m. Okay, so if any of your junior is starting preparing for GATE 25, you can tell him to attend this. This is a free workshop, and the link is there in the description of this workshop. So guys, moving further, this is about the ranks we got in engineering services as the results are out. AIR 1 from civil, mechanical AIR 9, 37. So these are, you can say, 5 in AIR 10, 29 in AIR 50, and 37 in AIR 100. Okay, so let's move further, guys. Now we are starting the session. And first of all, let us see about the system of linear equations. So my dear, when we are talking about system of linear equation, first of all, I would like to tell you what is the meaning of this word linear. When we say linear, it means any of the variable which is present in this system that will be having the power as 1 only. So you can see the power of x is 1, power of y is 1, power of z is 1. Okay, power of x is 1, y is 1, z is 1, x is 1, y is 1, z is 1, like that. And here also you can see x1, y1, z1. So power is always 1. That's why we are calling it as linear equations. Okay. Then my dear, when I am saying system means more than one equations are there. And when we are talking about this, this is classified into two categories. One is homogeneous equations and other is going to be non-homogeneous equations. So my dear, when we are talking about homogeneous equations, you can see in the right hand side you are having all the elements 0 in all the equations. When we are talking about non-homogeneous, here you can see d1, d2, d3 I have written. So if any of this d1, d2, d3 is non-zero, we can call it as non-homogeneous. So I have written it here that all not zero simultaneously. So out of d1, d2, d3, at least one should be non-zero. That is the condition. Okay, at least one should be non-zero. If any of them is non-zero, we will be calling it as non-homogeneous system of equation. So my dear, here what we are going to learn today is the type of solutions. That what are the types of solution we will be getting and what would be that solution. That is what we are going to learn today, and how we will be using the matrices in that. So before we go into that, and why we should use the matrices for that. So before we go into that, first of all, I would be giving you the types of solution which you are studying from your childhood. So my dear, the first case you are studying, like linear equation means you would be having straight line. Let us say I have a straight line like this, I have a straight line like this. Let us say we have two lines. So my dear, when these two lines are intersecting at one point, so you would be knowing that one point of intersection is x comma y. If these are two equations, let us say 2x plus 3y, okay, is equals to 5. Likewise, there is some 4x plus 1y is equals to 3. Likewise, if these equations are there, you can find out the intersection point. So this is one type of solution. and this solution is said to be unique solution. This solution is said to be unique solution. Okay, because you will be getting the point of intersection. My dear, what can be the second case? Second case can be that this is a straight line and another straight line is going to lie over this only. Another straight line is going to lie over this only. So my dear, when you are having this condition, when you have this condition, every point is acting like a solution because both the lines are intersecting at infinite points. So every that point is going to be what? Yes, Gaurav, I am fine. So every such point is going to be the solution. So this is the condition which we will be calling it as infinitely many solution. Infinitely many solution. Okay, or infinite solution you can say. This is the case number 2. Then my dear, we can also have a third case. We can also have a third case where we would be having parallel lines. You know, parallel lines never intersect. Rishabh, hello dear, how are you? So parallel lines are never going to intersect. So for this condition, I will be calling it as no solution. So what we learned till now, I am repeating for you guys, those who have joined late. So I told you that first of all, today we are going to talk about the system of linear equation. And when we are talking about system of linear equation, it simply means that we are talking about the equations where variables would be having a power of 1. Then my dear, I also told you that there are two types of such system. One is homogeneous, other is non-homogeneous. If your right hand side in all the equations are 0, we call it as homogeneous. If right hand side is non-zero, we call it as non-homogeneous. Then my dear, you may be saying, sir, D1, D2, D3 all should be non-zero. No, if any one is non-zero, it is non-homogeneous system of equation. So my dear, if D1, D2, D3 all will become 0, then only it will become homogeneous. So any one should be non-zero to make it non-homogeneous system of equations. And guys, today we are going to talk majorly about this only. Okay, we will see what kind of solutions are possible. But before we go into that, I told you what kind of solutions are there. One case is when these two lines are going to intersect at one point, we call it as unique solution. Okay, like this is about two lines. We can have 3 line, 4 line, 5 line, n line. Variables can be more than 4, 3, 5, 7, whatever. Okay. Thanks, Gaurav. Thanks for your wonderful words. And I will suggest you that you can join my Telegram channel also, Mechanical by Dheeraj Sardana. There you will be getting the handwritten notes also from my subjects which I take. And also you will be getting some useful PDF and other stuff. You can join that. And thanks for your wonderful words. So guys, when we are talking about this second solution, when one line and second line are going to be coinciding with each other, then every point will act like a solution. We call it as infinite solution. And if these are parallel, we will be calling it as no solution. This is generally we were studying in our childhood when we were talking about the linear equations normally. Then my dear, the point is when we can do like this, why we are going to study this in the matrices? Because if the number of variables are increasing, let us say 3, let us say 4, let us say 5, then it would be very difficult for us to solve like that. Okay, like these two equations you can solve very easily. But if you are having 3, 4, 5 unknown, 4, 5 equations, then solving is going to be difficult a bit. So that is why, okay, that's great, Gaurav. So that is why, my dear, we are going to have some alternate for that, which we are going to study right now today. So I would like to tell you guys here that when we are talking about, I already told you, linear means power of variables is 1. If any one of D1, D2, D3 is non-zero, we call it as non-homogeneous. As the number of variable increases, the solution will become lengthy. So that is why we want some solution for that. So now my dear, how we are going to solve it? That is the detail of that. So we have system of linear equations. So my dear, system of linear equations, we have already seen now. Now we are talking about with respect to the solutions. Till now we have seen when we will call them homogeneous, when we call them non-homogeneous. Here I am talking about for non-homogeneous, what kind of solutions we can expect. What kind of solutions we can expect. So my dear, the first type of solution we are saying is consistent. And second type is we are calling it as inconsistent. Like we have seen when the two lines were becoming parallel, they were not touching, not cutting. At that condition, we were calling them as no solution. So inconsistent means the same, the no solution. So for non-homogeneous system, we can have consistent solution, we can have inconsistent solution. But for homogeneous system of equation, we always have a consistent solution. So my dear, when we are talking about this consistent solution, it can be of two types. One is infinite solution, other can be unique solution. Other can be unique solution. Okay. So my dear, when we are talking about unique solution, we also call it as trivial solution. And when we are talking about infinite solution, we are having the non-trivial solution. So trivial means the same, unique. When two lines are cutting each other, you are getting the point of intersection. And this non-trivial means the same when two lines were going onto each other and you were getting infinite points of contact. So guys, now these are the three things in front of us. And by looking at any system of equation, we need to decide whether this system of equation is going to give you a unique solution or infinitely many solutions or no solution. And based on that, we are going to do a large number of questions as well. So guys, for that, we will be having a discussion. Okay. So we have already written three equations like that. Ki a1x plus b1y plus c1z is equals to d1. Then a2x plus b2y plus c2z is equals to d2. a3x plus b3y plus c3z is equals to d3. So my dear, as if I say d1, d2, d3 are not all zero. Not all zero. In that case, it is a non-homogeneous system of linear equation. So my dear, if you want to use the matrices to solve them, we should be able to write this in the matrices form. So we are writing this in matrices form like A into X is equals to B. Now what is A into X is equals to B? So in A, we are going to write all the coefficient A1, B1, C1, A2, okay, A2, B2, C2, A3, B3, C3, like that. And here we have X, Y, Z, here we have D1, D2, D3. Now my dear, when you are using this, this is the way we are writing in the matrices. Now my dear, when you will be observing in the form of matrices, if you are going to change any row, like you want to shift this row into this position, first row into third position, then my dear, if you are going to do this kind of shifting, never do the same shifting in X, Y and Z. Keep them same only. But whatever shifting, if the third row is becoming first row here, the same should happen here also. Then my dear, your solution will not change. That is the property of matrices. We have also seen at the time of matrices and determinant when I was teaching you that. So my dear, that is the thing. We can go for the row operation without changing the type of solution. So that is why, my dear, we are going to use those things for finding out the solution. So now we will see when we will be getting the no solution, when we will be getting the unique solution, and when we are going to get the infinite many solution. So what is the procedure for that? So my dear, you would be taking this matrix like that. Now we are going to define a special type of matrix that is said to be augmented matrix, which will help us to find out the final solution. Then what is augmented matrix? This is augmented matrix. So when we are writing it in this way, A1, B1, C1, A2, B2, C2, A3, B3, C3, we have removed X, Y, Z, and here you can put a line or dash symbols, and then you are writing D1, D2, D3. This is said to be augmented matrix. So my dear, when you are having this augmented matrix, now I am telling you the types of solution you are going to get. So my dear, I already told you how to find rank in the last class, and many students said that sir, similar question was there in the BARC exam also. Yes, very good, Bengali Baba. Okay, Bengali Baba naam rakha hai aapne apna. Sahi hai. So guys, when we are going to have rank of augmented matrix, which we have written like this, AB, if that is coming out to be equals to the rank of A, and that is also coming out to be equals to the number of variables, then my dear, this is the condition which we call it as unique solution, unique or trivial solution. Okay. If you are going to find out the rank that is coming out to be, but it is coming out to be less than the number of variables, then my dear, this is the condition of infinite solution, that is non-trivial. And if you are going to have this is the condition for no solution. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Then we are going to start the questions. Everybody is clear or not? Please tell me that. Everybody is clear or not? Please tell me that. Inconsistent means no solution. Now we are going to start the questions. Now we are going to start the questions. This was the concept I wanted to give you before starting, because we are going for concept plus question classes. Now we will be moving to the questions. So guys, the very first question we are going to solve it this one. This is from previous year's GATE. As many branches are there, I have not mentioned the branch here. So consider the system of simultaneous equations. These are three equations you can see. And they are saying you need to find out whether the system is having a unique solution, infinite number of solution, no solution, or exactly two solution. In the last class, I already taught you how to find out the rank. So we would be going with the same procedure. Are we ready for this? So first of all, our first step would be we will be writing the system in the form of matrix. 1, 2, 1, 2, 1, 2, 1, 1, 1. This is A matrix. Now to make it augmented matrix, we would be writing 6, 6, and 5. This is how we can write the augmented matrix. Now when you will be going for the row operations, by going for the row operations, you can find out the rank, because you know we need to convert it into row Euclidean form, which I told you in the last class. So when you would be trying for this, you would be getting to know about the rank. Will you try this or shall I do for you? Will you try this or shall I do it for you? Please tell me. Will you try this or shall I do it for you? Tell me. Will you try this or shall I do it for you? Okay. So you know how to convert it into the row Euclidean form. We want to make the zeros actually. Okay, I will do it. Don't worry. Don't worry. Okay. Fine, fine, fine. So I'm giving you 1 minute, you can try. Otherwise, we will start doing. Okay. So this is the matrix we are having. Now, my dear, we are going for some row operation. We want to make this as 0, this as 0, because we will try to increase the number of 0. So first of all, we will be operating on R3. R3 will be operated like R3 minus R1. And you can also operate on R2. R2 minus half of R1. Okay, because we need to make the, okay, Zakhmi Atma have already given the answer as no solution. Okay, let me see. Yes, the answer is definitely correct. Answer is definitely correct. Okay, so I feel I have done a small mistake. It is 2R1. Okay, we are going to apply this operation. When you will be going for this, here you would be having 1, 2, 1, 6. No change in the first row. You are approaching in the second row as R2 minus 2R1. So when you would be subtracting R2 minus 2R1, this term will become 0. And 2R1 is 4. 1 minus 4 is minus 3. Then you are going to have 1 into 2 is 2. 2 minus 2 is 0. 6 into 2 is 12. 6 minus 12 is minus 6. Okay. So this is the second row we are going to get. Very good, Zakhmi Atma. We are going for this third. 1 minus 1 is 0, because R3 minus R1. 1 minus 2 is minus 1. Then we can write what? Then we can write what? 1 minus 1 is 0. Yes. And 5 minus 6 is minus 1. Is it clear for everyone? Yes. Now my dear, you can see we are having these equations. Row Euclidean form is saying that when you are going from first row to the last row, the number of zero before first non-zero element should increase. Here we have 1 0 before first non-zero element. Here also we have first row. So it is not the row Euclidean form. We would be going once again for the operation. I am saying R3 is going to be. So R3 is operated as R3 minus 1 by 3 R2. When you are going for that, what you will be getting? First row is unchanged, 1 to 1, 6. Second row is unchanged, 0, minus 3, 0 and minus 6. Now you are going to say 1/3 of R2. So R3 is 0, 0 minus whatever it is, 0 is 0. It is minus 1, minus of 1/3 of 3. It is going to be minus 1 plus 1. It is going to be 0. Here also it will be 0. And when you will be going for minus 6, 1 by 3 of minus 6 will be 2. So it is going to be minus 1 plus 2 is plus 1. So my dear, if you see this, just feel now. This is the A matrix. If you see this A matrix, third row all elements are 0. In first row we have a non-zero element. Second row also non-zero element. So obviously the rank of A here is coming out to be 2. But if you see this complete matrix, then you can see in third row also one non-zero element. So the rank of augmented matrix AB is going to be 3. So rank of A is not equals to rank of AB. So that is why the system of solution would be having no solution, which is nothing but inconsistent. So one question is completed, guys. This is how we are going to do. Yes, good afternoon, Zakhmi Atma. Moving to the second question. This is the second question. So we are having around 10 questions on this topic to clear our concept about that, because every year we are expecting the question from this topic. This is the question number 2 for today's class. Try to solve it. This question is saying the following system of equations. Okay, and you need to tell, okay, leave this because this is homogeneous. We are doing for non-homogeneous. Do this. This is our second question. Today we are talking about the non-homogeneous, not homogeneous. Solve this one. This is a question from Electronics Branch 2008. You can write it as 422176. Try to solve it. This is easy question for all of you because it is a matrix of 2 cross 2. Solve this question, guys, and tell me the answer for this. Is this having a unique solution, no solution, infinite number of solution? Exactly 2 solution. Yes, Zakhmi Atma, Bengali Babu. Rishabh is saying no solution for this. Zakhmi Atma is also saying no solution. Very good. So guys, what you will be doing here, you will say R2 will be operated R2 minus 1 by 2 R1. So when you will be going for this, this is 427 and it is 0. It is 0. Then we have 7 into, this is 7 by 2 is 3.5. 6 minus 3.5 is 2.5. You can see rank of A not equals to rank of A by B. So no solution. Moving to the next question, guys. This is the question where they have given you this in the matrix form and they are saying this is having a unique solution, infinitely many solution, no solution, or exactly 2 solution. Try to solve this. This is question number 3 for today's class. So guys, today we are talking about the system of equations, and in this week we are going to have a session on PYQs of ISRO mathematics. Be ready for that as well. Solve this, guys. Try this, otherwise I will be doing it for you. Yes, yes, yes. First of all, you will be making the augmented matrix. Yes. Now you have to perform the operations. So you can say R2 is operated. R2 minus 3 by 2 R1. R3 is operated. We are going in the standard way. Make the multiples of R1 to make them 0. So when you would be going like this, R2 minus 3 by 2 R1. 3 by 2 of 2 is 3. So you know first row is unchanged, 2, 1, 3 and 5. For second row, 3 minus 3 by 2 of 2 is 3. It is going to be 0. Then 3 by 2 of 1 is 3 by 2. So minus 3 by 2. 3 by 2 of 3 is 9 by 2. So 1 minus 9 by 2. So minus 4 minus 15 by 2. Now you know when you will be going for R3 minus 1 by 2 R1, it is 0. 1 by 2 R1, 1 by 2 R1. So it will be coming out to be minus 3 by 2 or plus 3 by 2. Yes, anybody have done it? Okay, unique solution, Bengali Baba is saying. Let me check. I have written the answers for you. So you are saying unique solution. Rishabh is saying infinitely many solution. So the answer is infinitely many solution. Here you would be getting 3 by 2. When you will be solving this, 5 minus 1 by 2, you would be getting 7 by 2. Then when you will be having 14 minus 5 by 2, you will be having 23 by 2. So if you see, now I can see the second and third row are same, only with minus sign differences there. So I can operate R3, where R3 minus or plus R2. When you will be going for this, there is no change in the first row. 2, 1, 3, 5. Second row will also remain unchanged. Minus 3 by 2, minus 7 by 2, minus 23 by 2. Third row will become 0. So you can see as the rank of A is equals to rank of AB. So system of equation is consistent, but it is less than 3. Variables are 3. So it would be having infinitely many solutions. B is the correct answer for this. Everybody got it? So Rishabh have given the correct answer for this question. You got it, Zakhmi Atma? Okay. Very good guys. So moving to question number 4. Moving to question number 4. This is a NAT question. Very good, Vishnu. Here, once again, the equations I have given, you need to find out the value of K for which system has infinitely many solutions. You will make the augmented matrix 1 minus 2, 3 minus 1, 1 minus 3, 4 and 1, minus 2, 4, minus 6 and K. TPM is saying K is equals to 2. Okay, what about others? TPM is saying K is equals to 2. What about others? Very good TPM. Very good TPM. So here if you will see, you would be saying R2 minus R1. And R3 will be operated as R3 plus 2R1. So when you would be going for this 1 minus 2, 3 minus 1. 1 minus 1, R2 minus R1. 1 minus 1 is 0. Minus 3 plus 2, minus 1. 4 minus 3, 1. 1 of minus 1, minus plus 2. Then you know when you will be having 2 times R1. 2 minus 2 is 0. Minus 4 plus 4 is 0. 6 minus 6 is 0. 2 into minus 1 is minus 2, K minus 2. Yes. Very good, very good, very good, Vishnu and Zakmi Atma. So my dear, here if you want rank of A, it is simply 2. Rank of A by B, augmented matrix, it can be 2 or 3, depending on the value of K minus 2. If K minus 2 is becoming 0, then it would be 2. And for infinitely many solution, we want rank of A equals to rank of A by B, that is less than 3. That is 2. So that is only possible when K will become 2. So the answer for this is 2. Moving to question number 5, guys. Moving to question number 5. Very good. So this is once again asking the same, the system of solution. So I have taken this much number of questions for good practice. So if any student is preparing for GATE, ESE, ISRO, for all 3 exams, this session is useful. So this is the question number 5. Solve this. This is 2 minus 1, 3, 1. 3 minus 2, 5, 2. Minus 1, minus 4, 1 and 3. This is augmented matrix. You need to tell that this system of equation have which type of solution. So likewise, we are having around 10 questions. Concept I already told you. In the last question, I also will tell you how to find out the value of that solution. What will be X, what will be Y, what will be Z if we are at unique solution. Okay, that also we will see. Try to go for the operations. R2 is 3 by 2 R1. R3 is R1 by 2. Okay, so Zakmi Atma is saying unique solution for this question. Yes, you are correct. Very good TPM. Very good TPM. So guys, here you can see R2 minus 3 by 2 R1. 2 minus 1, 3 and 1, that will remain the same. Then 3 by 2 of R1, 3 by 2 of 2 will be 3. So minus 3, 3 minus 3 is 0. Then minus 2, this is 3 by 2 of 1 is 3 by 2. Minus 3 by 2, it is minus minus will become plus plus 3 by 2. Minus 2 plus 3 by 2 is minus 1 by 2. And then 3 into 3 by 2 is 9 by 2. 9 by 2 is 4.5. Minus 4.5 is 1 by 2. Then you are going to have this to be 0. Then minus 1 will be multiplied by 2. It will become minus 1 by 2. It is minus 3 by 2. And also here you would be having 1 into 3 by 2. Minus 3 by 2. 2 minus 3 by 2 is 1 by 2. This is 3 by 2. 1 plus 3 by 2. Okay, and then you can have this 1 by 2, 3 by 2, it is 3 by 2 minus 2 by 2, it is 1 by 2. Are we getting this? Yes, very good, Papa ka ghoda. Are we getting this? So when you are having this, now you can do one more thing, that you can multiply R3 plus 3R2. So when we are going to do this, it is 2 minus 1, 3, 1. 0 minus half plus half plus half. Okay, then 0, it will become 0. So 3R2, 3 by 2, 5 by 2 plus 3 by 2, 8 by 2 is 4. And it is 1 by 2, 1 by 2, 1 by 2, 1 by 2 plus 3 by 2. It is 4 by 2. So you can see here rank of A is equal to rank of A by B is equals to number of variable 3. So you would be having the unique solution. Okay, you would be having the unique solution. So I am telling you how to find out that solution. I feel final matrix we were getting as yes. Okay, whatever you are getting, you just need to do one thing. Like let us say here you are getting A1, here you are getting B1, here you are getting C1, here you are getting D1. So you just need to do like that. A1x plus B1y plus C1z is equal to D1. So in other words, here you can do one thing. Like here you are having 2. So first equation is 2x minus y plus 3z is equal to 1. Second will give you this. Third will give you this. So from the third equation, you will get the value of one variable directly. Good afternoon, Papa Ghoda. Okay? So don't worry, here they have not asked, but one question I have kept where they have asked the solution. There I will show you that solution also. Is it correct? I have done it correctly. Minus 3 by 2, 5 by 2. Yes, everybody? Have I done it correctly? R2 minus 3 by 2, R3, R3 plus R by 2, R3 plus R by 2. So minus 1, this is becoming 0, minus 4 plus 1 by 2. So minus 4 plus 1 by 2. It will be minus, not, I feel there is some mistake. This I have not done correctly. Is it correct or not? Please tell me. It should be minus 9 by 2, I feel so. It should be minus 9 by 2. Because minus 4 minus 1 by 2 will be minus 9 by 2. So after solving, I am writing the correct one. You would be getting. Otherwise, the student who watched recording, they may get confused. So I am writing the correct value after solution. So you would be getting for this. Here we are getting minus half, plus half, and plus half. And lastly, here we have 0, 0, minus 2, and minus 1. That is what we get. So if we have this, I am writing this equation. Look at it. So finally we get 2 minus 1, 3, 1. 2 minus 1, 3, 1. 0 half, 0 minus half, plus half, plus half. Then we have 0, 0 minus 2, minus 1. So now what you need to do, guys? Good afternoon, Pradeep. Very good, Vinay. So what you need to do now? Yes, college learners, good afternoon. So now you know you would be putting x here, y here, z here. You will make the first equation from here. This is constant. So you will say 0x1, 0y1 minus 2z1. So minus 2z1 minus 2z is equals to minus 1. From here you can get z. Then you can write minus half of y plus half of z is equals to 1 by 2. Z you are having, put it here, get the y. Then you can write 2x minus y plus 3z is equals to 1. You know z, you know y, you can get x. This is that unique solution. So whatever the unique solution you have, you can find out with the help of this. Moving to the next question, guys, question number 6. Once again, you need to tell whether this system of equation has a unique solution or it is having infinitely many solutions. Yes, they're asking the only possible values for A, 0, either 0 or 1, 0, 1 or minus, and any real value other than 5. For that, it will be having a unique solution. Try to solve this question, guys. Pradeep, Vinay, Papa Ghoda, Vishnu, learner, Zakmi Atma, everybody. Please try to solve it. I am writing the equation 1, 1, 2, 1. अरे भाई मैथमेटिक्स है, कैलकुलेशन मिस्टेक किसी से भी हो सकती है, तो इसलिए ध्यान रखना, बी केयरफुल वाइल कैलकुलेटिंग. 1, 4, A, 4. Augmented matrix is ready. Now you can start solving. Question number 6 it is. You know, here we can operate R2 minus R1 directly and R3 minus R1 directly. Solve it. Okay, Papa Ghoda is saying C. I feel you need to check it, dear. You need to check it. You are saying 0, 1 and minus 1. Please check it. Good afternoon, Ankit. So try to solve it. When you will be operating these operations, 1, 1, 2, 1, 0. 2 में से 1 गया 1, 3 में से 2 गया 1, 2 में से 1 गया 1. Then you have 0, 3. This is A minus 3, A minus 2. And then it is 4 minus 1. So my dear, now you would be saying that R3 should be operated R3 minus 3 R2. So when you would be operating like this, 1, 1, 2, 1. Anybody find the answer? Okay, Rishabh Yadav is saying the answer is D. I feel that is the correct answer. So when you would be having here 0, 1, 1, 1. Now R3 minus 3 R1. This will remain 0. 3 minus 3 will become 0. This will become A minus 5 and 3 minus 3. 3 minus 3 will become 0. Is it like that? So my dear, you can have unique solution only if rank of A is equals to rank of A oblique B is equals to 3, which is only possible if this number is non-zero. Because if this number is non-zero, the rank of A oblique B will become 3. Otherwise, if this is 0, then rank of A oblique B will become 2. So that is why A minus 5 should not be 0. A should not be 5. So you can have any number other than 5. Very good TPM, very good Pradeep. Sorry Pradeep, your answer is not correct. The answer will be D for this. Clear for everyone? This is question number 6. It was a good question. Answer for this is D. Moving to question number 7. Moving to question number 7. Moving to system question number 7. Yes. Solve it then. It is similar question. This system is consistent if A, B, C satisfy the equation. Once again, you need to apply the same thing. 1, 2, minus 3, A. 2, 3, 3, B. 5, 9, minus 6, C. And you are having this augmented matrix. Is it clear for everyone? Please solve it. Solve it, guys. Fine, guys. So when you will be solving this, once again you need to apply the same. You would say R2 is operated as R2 minus 2R1 and R3 will be operated as it is R3 minus 4R1. When you will be going for this 1, 2, minus 3A will remain the same. Then you are saying R2 minus 2R1. This will be 0. 3 minus 4 is minus 1. 3 minus 6 is minus 3. And it will be B minus 2A. Then you are having this 5. 5 minus 4 is 1. 9 minus 8 is 1. Then you are having this minus 3 into 4 will be minus 12 plus 12. So minus 6 plus 12 is plus 6. Okay, is it correct? Then you would be having C minus 4A. Okay, TPM is saying the answer to be B. The answer to be B. Okay, fine. Even I could apply one simple operation also, like we have done. We could also do. I am telling you one more operation that will be more much better. You can also go for, like you are saying, R3. R3 can be done. R3 is R3 minus 2R2 minus R1. That could be done. That could give you the better result and will be coming in the first or second attempt. So we are going for that operation. That will be better. Okay. So when we are going for that operation, I am telling you how we will be getting it. So we are going for this. R2 is nothing but R2 minus 2R1. So when we are going for this, you are going to have 1, 2, minus 3. So answer given by TPM and Papa Ghoda is B, and that is correct. B is the right answer. So you would be having here 1, 2, minus 3 and hey. R2 minus 2R1. It will be 0. Minus 2R1. So 2 into 2 is 4. 3 minus 4 is minus 1. So you have minus 3 into 2 is minus 6. So it is going to be 2 times, no? 2 times is going to be minus 6. And 3 plus 6 will become 9. And here you would be having B minus 2A. Then we have R3 minus 2R2 minus R1. So 5 minus 4 minus 1. It will be 0. Then you would be having 9 minus 6 minus 2, 1. Then minus 6 minus 6 minus 2 times of R2 means minus R1 means, so it would be minus 12 plus 3 minus 9. So you are having here C minus 2 times of B minus A. This is the equation. Now, my dear, we are given that this is the system is consistent. Consistent means the rank should be equal. So you can say, first of all, if I am going to do R3 plus R2. So I would be getting 1, 2, minus 3 and A. 0, minus 1, 9 and B minus 2A. Then 0, 0, 9, 9 will be 0. It would be C minus 2B minus A plus B minus 2A. So when you would be saying that the rank is going to be equal for them, it is possible if this term will become 0. So rank of A should be equal to rank of A oblique B, because the rank of A is 2. So if rank of A is 2, it should also be 2. For that we should be having C minus 2B minus a plus b minus 2a should be equals to 0, and the answer is 3a plus b minus c is equals to 0. B is correct answer. Very good, guys. Moving to the next question, question number 8. Okay, I feel question number 8 is in the starting. Question number 8, guys. Now this is question number 8. Here the question is, for what value of k the system is inconsistent? For what value of k the system is inconsistent? So guys, do like and share the session. We are at the completion right now. Tell me the answer for this question. Yes, very good, Pradeep. So I feel now everybody got it. Now solve this question. I want answer for this question also from your side. Find out the value of k. The equation will be 1 1 1 1 2 1 4 k 4 4 10 k square. Find the value of k for which the system is inconsistent. So here you will go for R2 minus 2R1, R3 minus 4R1. Solve it, guys. R2 minus 2R1, first row will remain unchanged, 1 1 1 1. R2 minus 2R1, 0. R2 minus 2R1, minus 1. R2 minus 2R1, 2. R2 minus 2R1. R3 minus 4R1. R3 minus 4R1. R3 minus 4R1. Okay. So you can have, I feel this is the final form. Okay. So what would be the answer for this? So if you want the system to be inconsistent, the rank of A should not be equals to rank of A augmented B. So you can say here for that k square minus 4. It could be anything. Okay. But when we are talking about k square minus 2, it could be anything, because if even it is 0, then also this is already present. So the rank of A and rank of A oblique B will be always be equal here. So I feel actually there is a mistake in this statement. As per my statement, here it is 1. So when here it will be 1, then you would be having the answer will be different, and that is the correct answer. So here this is the misprint actually. Okay. So I have already checked it. This is the misprint. Here 1 will be coming, and then you will solve it. You will get the right answer. So this is a misprint, actually typing error you can say. Okay. Otherwise you will never get the system to be inconsistent. So you would be having here 1. Now you can solve it. 1 1 1 1. This is 2 minus 2 is 0. 1 minus 2 is minus 1. 4 minus 2 is 2. K minus 2 is K minus 2. Now R3 minus 4R1 will be 0. 1 minus 4 is minus 3. And 10 minus 4 is 6. And then you are having k square minus 4. Now you can see R3 will be operated. R3 minus 3R2. 1 1 1 1. 2 minus 1. 2 k minus 2. R3 minus 3R2. R3 minus 3R2. R3 minus 3R2. 0. 0. K square minus 4. 3R2. k square minus 3k. Now you can solve it. So if you are having k square minus 3k minus 10, you would be getting the answer for which you are looking for. For inconsistent, the rank of A should not be equal to rank of AB. That is the condition only. Will it be fine? Okay, fine. So guys, this was the system of equation session, and I feel we have done around 10 questions on this, and I feel not 10 exactly, but 8 to 9 questions. So this was system of equation. Now we are going to meet once again for mathematics in this next week. Not in the only Saturday, Sunday, but this time on some weekday we will be having a session of ISRO PYQ of mathematics. So just ready for that ISRO PYQ of engineering mathematics, and then after that on Saturday, Sunday we would be having the session of eigenvalues and eigenvectors, and we will complete this chapter as well. And after that we will be having only practice sessions for differential equation, for calculus, for probability, for all other chapters. Okay. Because now I feel exam is near, you guys are more interested in questions because majority of you are looking for the practice sessions. So we would be coming with wonderful practice sessions, and we will be taking some very good questions, not only from the previous years, but from the different sources, because if you see last year, many new types of questions have been seen. So these sessions would be very helpful for GATE and ESE both. So goodbye guys for this particular session. We'll meet again. And for ISRO, if you are from mechanical, then ISRO sessions would be there. The next ISRO session will be on Tuesday. Okay. So Tuesday will be the next practice session for ISRO. Okay. So goodbye.